everybody. Hi. Welcome. It's nice to see all of you today. We have a great turnout for a very interesting speaker today. Our guest is Paul Leonardi from Northwestern University. He did his undergraduate work at a small little college up in the San Francisco Bay Area, St. Mary's College, a very small little liberal arts college. He did his master's degree, he got his degree in communication there. He got a master's degree at Colorado, also in communication studies, and did his PhD at Stanford University in industrial engineering. He graduated there in the year 2007 and went on the faculty at Northwestern University, where he has been ever since.
All those years.
All those years. He actually has appointments in 3 schools here. School of Communication, in the McCormick School of Engineering in the industrial engineering area, which is where he did his work in his PhD, and at the Kellogg School of Management, the business school of Kellogg. Now, he wrote a dissertation, and this is for those of you who are doctoral students in the room. And he must have written a pretty decent dissertation, because it didn't win 1 award, it didn't win 2, it didn't win 3, nor 4, but 5 dissertation awards, including the Gerald R. Miller Dissertation of the Year Award from the National Communication Association, the Jerry D. Sanctis Dissertation Award from the OrgComm Information Systems Award, the Best Published Paper Award from the OrgComm Information Systems of Academy of Management, and honorable mention in the Charles Redding Dissertation Award in the OrgComm Division of ICA. That, in my book, sounds like a pretty decent dissertation. He's won a number of other awards as well, but you can look at his vita if you wanted to see what they are. Paul has published so far 14 articles in top-rate journals. These include the Social Studies of Science, Organization Science, Communication Theory, Human Communication Research, Academy of Management Journal, Communication Research, and a number of others. Now, Paul has done a lot of interesting work in the role of technology and communication in organizations, and he's going to talk to us today on thinking about technology, turning technology into a resource for network change. Help me welcome Paul to our...
Well, introductions are always so embarrassing. Thanks, Peter, for that very, very nice one. It's a pleasure for me to be here today and to talk with you about a paper that's a pretty rough project. And maybe some of you have seen a copy of the paper. I think it's floating around. What I'll talk to you about today is a bit of an evolution of my thinking in that paper since I wrote that draft. And I'm looking forward to some great feedback from you on how to improve these ideas in here. Because as I mentioned, they're rough. Did I say that enough times? Rough ideas that I'm going to present to you today. You'll notice that the title has changed a little bit from what perhaps was on the flyer, again, indicating some evolution of my thinking. But I want to start off by talking a little bit about my research, and so you can get a sense of how this paper that I'm going to present fits into my larger research stream. I'm interested in the relationship between technologies and the way that people communicate. In particular, how people share information, how they share knowledge, how they seek advice from one another, how they talk. And for me, thinking about these kinds of relationships in a recursive way is really important. So we know from lots of empirical studies that the way that people use technologies, right, if you follow that red arrow, can shift their patterns of interaction. We know that people's patterns of interaction can mediate their uses of technologies, right? So if you follow the blue arrow, we know that people, when they organize differently, find new needs, find themselves with alternative goals, and then have to reconfigure or redesign a technology to help them meet those goals. So there's a lot of relationships, a number of relationships going on between technology and patterns of communication and social interaction. And for me, these things together are really what I consider the process of organizing. So how people are communicating with one another around technologies, with the help of technologies, or perhaps through technologies. So these are the kinds of issues broadly that I'm interested in. And there's two general questions that really guide most of the research that I do. And the first, and this is kind of poorly worded, I didn't know how to put it on the slide, but why does technology sometimes change? And then why do organizations or communication systems sometimes change? So it's not necessary that an organization that's using a new technology is going to change its patterns of communication. Sometimes they just change a technology. Right? They either use it in different ways or they'll redesign the technology. So sometimes the technology changes, sometimes people's patterns of communication change. And sometimes when those changes happen, and I would say this is more often than the case than not, people come to think that those changes had to be that way. And so I'm interested in interrogating both of these questions. And I try to do that by looking at a couple different sorts of concepts. One is thinking about how technologies are framed, how people interpret them, how they make sense of them, and then how technologies and systems of communication or patterns of communication co-evolve. And then you can see how my research has kind of gone and looked in these different areas and trying to figure out, did these concepts make sense in explaining or helping to answer some of these questions? And these different papers try to focus on different mechanisms by which technology and communications practices become intertwined. So what I want to focus on today is right up here in this upper right-hand quadrant, thinking about how framing interpretation of a technology lead people to think that certain changes had to be the way that they were. So why is it that you get an organizational change and the people say, well, of course, that's the organizational change that we knew was going to happen, and that's the only one that reasonably could have happened. I don't think that it is the only one that could have happened. In fact, I'll show you another one that could have happened. I'll show you one that didn't happen. And we'll hopefully see a little bit why these people had a fairly deterministic kind of understanding of the actions that took place. So the questions that will guide today's talk are the following. How do implementation strategies affect the way that people use a new technology? And why do technologies sometimes bring change to communication networks and other times not, even when those technologies are being used? Okay? So let me start off by saying, well, why are these important questions in the first place? At least why do I think these are important? One is because there's a fairly scary number that more than 75% of new IT implementations fail. That means organizations are spending a lot of money implementing expensive technologies. Right? In the case I'll present to you today, it's a fancy simulation, computer simulation technology for engineering. It could be an enterprise-wide software. But organizations spend lots of money implementing these kinds of technologies, and the vast majority of these implementations fail. And failure here should be qualified as not bringing about the kind of change that those who implemented it expected. We know, though, that technologies are often implemented with change goals in mind. This is something that's overlooked oftentimes in academic literature, but if you talk to managers at organizations, they don't just implement a technology for the fun of it. Right? They do it because they want to drive some particular kind of change. And so it's nice to talk about change as being an emergent process, right, that can happen after a technology. And while that does often happen, people have specific goals for the kind of changes they want the technologies to bring about. And recently, there's been more of a growing recognition of this amongst management and organizational researchers in the role of implementers, trainers, technical writers, and other folks who sort of traffic in introducing new technologies into organizations, and the roles that they play in trying to pursue specific goals for change. The final kind of trend that we see is that these different parties, implementers, trainers, managers, users, are increasingly linked tightly together. They're linked within the same company. There's been a trend for many high-tech companies to build their own software in-house, or they customize software that they buy from external vendors. They're linked together by contractual agreements, by strategic alliances, lots of ways that developers and users of technologies become quite close together, such that it's easy for users to say, we want to change the features of this tool, and they can either do it themselves or they can get someone with the technical acumen to do it for them. So I proposed several questions, right, to start to guide this study. And let's look at some existing theory to help figure out if we can answer them. Well, we know a few things from the last 2 decades of research in this area. One of perhaps the most important is that new technologies are, to use Carl Weick's term, equivocal. meaning that a single technology can be interpreted in a variety of different ways. People can make sense out of it differently, depending on changes in their context. We also know, drawing from a slightly different stream of literature, that talk, everyday communication practices, create a discourse that guides sense-making. Now, I have this capital D underlined, right? It's kind of this funny annotation here that scholars in discourse and conversation analysis use to distinguish little d discourse, which is everyday talk, with big D discourse, which is more synonymous with ideology. Right? I would probably use the term ideology. So that talk creates an ideology that guides people's sense-making. Right? It constructs a frame of reference that people then use to sort of evaluate their actions. And we know from lots of research that the broad discourse, right, those ideologies, often structure people's interaction with other people and with objects. But there's one problem when we think about trying to understand the role of talk, discourse, in getting people to use a technology. And that is that we have lots and lots of good research, right, and I put here many others, and there really are many others, that show that technology use is not a dichotomous variable. It's not that people either use a technology or they don't, but there's lots of gradation and lots of variations that exist in how people can use a technology. So it's not just that talk will encourage someone to use it, but it's also possible that those broad kinds of ideologies that are created from how people talk about a technology might help to shape how technologies are used. So the way that people combine various features that can operate interdependently of one another, the way that they redesign the technologies, so those micro practices of use can become shaped, perhaps in some way, by those broad ideologies that are created around the use of the technology. So to sort of illustrate this difference, a typical approach that you often see in the literature is that you might say, well, there's certain framing strategies that people use. Those framing strategies create a broad discourse or ideology that then influences if the technology will be used. So rather than do that, let's take a slightly different approach and say, if we know that frames can create a discourse, can that discourse influence how people use a technology? And more importantly, can that discourse then help to justify for people the kinds of changes that they see after they use the technology in these varied ways? Okay? So, in thinking about discourse, or these broad ideologies, I stumbled across a few years ago this great quote by McGregor of X and Y fame, theory X and theory Y in organizations, if you studied that. Right? And McGregor said the following about influence and persuasion. He said, the power to influence others is not a function of the amount of authority one can exert. It is rather a function of the appropriate selection of the means of influence which the particular circumstances require. So if you're an implementer or a manager and you're trying to implement a technology to drive a particular kind of organizational change, McGregor would say we need to focus on the kind of talk, right? The kind of influence that's being used to try to convince people. I've made an argument in a couple papers now that a discourse of technological determinism may be one of these means of influence that's particularly useful in contexts where people are using new technologies and where technologies are implemented to drive organizational changes. Now, there's lots of debate about whether technological determinism, right, is empirically valid or not. That's not a question I'm interested in this particular study. Instead, I'm interested in, is there a power that the use of an ideology of technological determinism might have on the way that outcomes unfold in organizational contexts? Generally, the concept or the idea of technological determinism follows two guiding propositions. The first is that technologies evolve linearly according to principles of science, that one technology begets another, which begets another, which begets another, and that humans actually don't intervene much in that natural evolution. The second, and this is about technology development. The second is more about technology use, which is that technology causes orderly changes in the social world that have everything to do with the actual qualities of the technology and can override lots of human intervention in the process. So you've probably heard this kind of talk, right? You read it in the papers all the time, right? Technology's changing things in these big ways. Technology brought about this kind of change. Now, technology certainly might enable these things. It's less clear empirically whether technology determines it, but that discourse exists out there for lots of people. And we're going to see it operating in the case I'm going to present to you. So let's talk a little bit about that case and the company that I studied. The company is cleverly disguised as Autoworks, also known as General Motors. And Autoworks is one of 3 big American automotive companies that recently went through bankruptcy in the US. And I'm going to be talking today about 2 groups in Autoworks who are doing a type of job called crashworthiness engineering. And I'll talk about that in a minute. And these groups are also cleverly disguised as the piston group and the strut group. Okay, so 2 different groups. And just so you get a sense of how this is laid out, Autoworks, right, is this big multinational company. It has corporate functions like advertising, marketing, finance. It has engineering, manufacturing functions. And within engineering, there's a safety division. And each of these 2 groups works in the safety division. So you can imagine that one of them designs a Honda Accord and another one designs a Honda Civic, right? So they're doing equivalent kinds of design, but just on 2 different vehicles. Now, crashworthiness engineering actually does, as Volvo says, it designs vehicles to look like this. What they're interested in is converting the kinetic energy, right, of a moving vehicle into heat, right, that gets dissipated, right, as the front structural members or the rear structural members crash, so that that kinetic energy doesn't get transferred into the occupant compartment. Right? So this is the whole idea of a crumple zone, right? You hear on car advertisements, and why if you buy a car, it costs $2,000 to replace your bumper, because it's designed to fail so that it gets damaged and not you. And this is the work of crashworthiness engineers. And crashworthiness engineers do this kind of work primarily, these days at least, with advanced simulation technologies that create mathematical models of vehicles and run them into virtual other vehicles and virtual walls and all kinds of virtual things, so that Autoworks and other companies don't have to spend so much money developing pre-prototype vehicles. It costs about $700,000 to build one of them, or sorry, to crash one of them. To build is an entirely different cost. So they want to move towards virtual analysis as much as they possibly can. So in part, in order to do that, engineers in Autoworks' R&D department developed a tool that they called CrashLab. And this is the interface for CrashLab. And CrashLab is a software that's supposed to help automate a lot of the work of building and analyzing crash models. And to use some engineering terms that hopefully are not too scary, you pre-process a model, which means you get it ready to run a simulation, and then you post-process the model, right? Much like when you write computer code. You post-process the model after you run the simulation to figure out what happened in the model. And so this technology, developed by engineers in Autoworks R&D, was meant to automate how engineers pre-process and post-process their models. Right? And why would Autoworks do this? Why are they developing a technology to automate the work? Well, let's hear from a senior manager at Autoworks who has a pretty clear and, in sort of communication terms, a relatively sophisticated understanding of the kind of changes they hope CrashLab will bring. Manager says, one of the objectives of automating engineering work is we want our engineers to spend less time struggling to set up models. CrashLab automates these procedures so engineers don't have to worry about them. So if they're using the tool, consultation will hopefully happen in different areas. I hope the discussion among crash engineers will be related to areas related to the analysis of their models. I'd rather see an engineer spending 30 minutes or an hour with another engineer saying, you know, based on your experience, how should I design this bracket? Or how can I design this structure so it gives me maximum energy absorption? You know, dummy. Real engineering questions. Not boring model setup kinds of things, but how do we analyze and come up with alternative designs for the vehicle? That's where we want people spending their time. And he says that's where we want them interacting with one another. We don't want them saying, hey, how do you set this thing up? Those should be standard work procedures. We want them to be doing more of that unstandard kind of work of troubleshooting and redesigning these models. All right, so let me tell you a little bit about the data I collected, how this all fits in, and then we'll get into some of the analysis. I spent about 2 years at Autoworks, and really about 9 full months over a 2-year period, and collecting data in a variety of different ways. I was able to participate in observing 24 different implementation events. And what an implementation event basically is a meeting where engineers sat there and got told what CrashLab was supposed to do. Right? Trainers perhaps told them, managers told them, developers told them, this is what CrashLab is supposed to do. This is how it's going to change what you currently do when you work. So I was at 24 of those events. I conducted lots of interviews with people all over the organization. And important to the analyses I want to show you today, I conducted a number of really detailed observations that usually lasted anywhere between 4 and 5 hours with engineers in these two different groups, the piston group and the strut group. And the reason I picked these two particular groups was because they were both at the same place on Autoworks' vehicle development process, meaning that they started, even though they were designing different vehicles, they started the rough schematics at the same time, and they were approaching similar stage gates. So they were doing roughly equivalent work at the same time so that it could be a nice comparison between these two groups. And I conducted 64 of these observations across all the team members in the piston group and 60 with the strut group. Collected lots of artifacts, screenshots like the one I presented to you before, photocopies, notes that they jotted down, pictures that they took when they were working with the actual hardware. And then I also distributed a set of questionnaires, and I'll talk about how I came up with those a little bit later. But network questionnaires basically asking them about their advice-seeking practices. And I submitted those in 3 waves right before CrashLab was implemented, approximately 3 months after CrashLab was implemented, and then a full year after CrashLab was implemented, to be able to see if there was any changes in who they communicated with over time to do their work. And then I also sent weekly a project tracking log, basically, to all these engineers who were in these two groups with all of CrashLab's features indicated on it, asking them to check off which features they used that week. So I had a log each week, right, for 52 weeks, basically, of what features they used. And I harassed them, and everybody got them all in. So these are the data that we'll talk about today. Primarily, an ethnographic study supplemented with a few other data collection kinds of techniques. So I want to talk to you about framing and discourse. And as I sat in these implementation meetings, right, at these different implementation events, listening to engineers learn about CrashLab, watching the implementers and the trainers talk about it, what I began to hear were these discourses of technological determinism, right? These broad ideologies of technological determinism being created through some concrete framing strategies. But I heard 2 different kinds of discourses being created, and I didn't expect to hear this, right? I heard one that was a very narrow, very focused kind of discourse. This is exactly how the technology is going to change the way you work. And then I heard a broader discourse. Here's generally how the technology is going to change the way you work. And we don't have time today to talk about all of these different framing strategies, so I want to just highlight one from each of these groups for you to get a sense of what these engineers were hearing when they sat in these implementation events. So the first comes from this narrower discourse, a very specific kinds of set of rhetorical practices about what the technology should do. And here we have an interaction in a staff meeting between a manager, denoted as M, and one of the engineers. And it goes like this. Manager's talking about CrashLab, which hasn't yet been implemented. And he says, apparently CrashLab is supposed to help us with an issue near and dear to my heart, making sure we stay ahead of the vehicle development process curve, right? And so everyone sort of chuckles, right? No, really, I talked with Sunil and some of the other focus group members about these automation functions. And it sounds like the barrier positioning and accelerometer placement functions actually work really good and will save you lots of time. And so the engineers say, well, do you know how the algorithm works behind that? I'm just curious, as a good engineer might say. And the manager says, as a typical manager might say, I don't know, but do you remember Brett Pascal, who used to work in another group? I think he was involved in it, so you could ask him. If you're sitting in this meeting, what's the one thing that you know about CrashLab? What's it supposed to do? Speed up the way you work, right? It's supposed to save time, right? And the manager goes on to say, in this meeting, managers in other meetings say, because it will speed up the way that you can pre-process your models, it'll save you lots of time in doing this model building, and you'll have lots of time left, right, to do more work. So folks that hear this narrow discourse get this very focused understanding that the technology is going to speed up the way they work. That's what CrashLab is supposed to do. If you heard a broad discourse, you heard something similar, but not nearly as focused. So look here at this interaction between 2 engineers in a training session and trainer T. The first engineer who's reviewing the program, the CrashLab program, says, are these procedures required? Because that means that you can't skip any of the steps. And the trainer says, well, you have to do it this way to make some kind of crash test thing that they need to do. You need to set up this IHS reference plane in order to do the kind of calculations. And the second engineer says, well, that seems sort of annoying. That means we have to change our order of operations. And the trainer says, well, I know, new tools require changes to work. I think to use CrashLab, you'll have to do things differently. There's really no way around it. And then one of the engineers chimes in, well, I guess that's right. So if you heard this broad discourse, what do you think CrashLab's going to do? Maybe make work? You don't really know, right? There's no specificity here about what CrashLab's supposed to do, other than suck it up, your work's going to change in some way, and you better get on board with it. But you don't know how it's supposed to change the way you work. And this distinction between this narrow discourse and this broad discourse is going to prove quite important as we go through the rest of these data and try to understand a little bit what happened. Before we get there, though, what I discovered as I was sitting in these observations, in these different implementation events, was that at a training session, there tended to be either members from the piston group or members from the strut group. There wasn't a whole lot of mixing of people from different groups, and that has to do with lots of scheduling, right? Why someone was able to go to one training event and not another. There were managers, right, that just talked to their specific groups, and the managers had different knowledge about the development of this tool, right? So they had different understandings from the developers in R&D about what it was supposed to do. Piston group managers were more involved with the development and had a sense that it was kind of supposed to help speed up the way that people worked, maybe. And the strut group managers didn't have that same kind of understanding. And so if you look at the breakdown, right, of the average number of frames, remember there was kind of 3 frames for each of those different discourses that I showed you before. If you look at the breakdown of the average number of frames that the average engineer in each of these groups was exposed to, you see kind of an interesting juxtaposition. That you have members of the piston group heard a lot of narrow frames, right? Or a lot of narrow discourse of determinism. So they heard technology is supposed to speed up the way you work. And the members of the strut group, by and large, didn't hear that same message. They just heard technology is going to change the way you work in some way. I'm not quite sure how, but it's going to change it in some way. So there's a difference in their exposure to these different frames throughout the implementation events. Now, if we take a look at those tracking logs I told you about, where I asked them to signal what features they used, right, throughout the 52 weeks, and you look at the piston group, and you look at the solid line there, right, is the number of the features that they used, and the dashed line is the number of engineers in that group using the features. You see that use starts off pretty strong, and there's 12 features in CrashLab. And almost all those features are being used by the majority of engineers for the first couple weeks. And then there's an inflection point around week 13. And very quickly, these lines drop off. Now, if you look at the strut group, you see a very different pattern. You see the same inflection point, but not so dramatic, right around week 13, right? The numbers start to drop off. But they stabilize at a much higher number of average feature use than they do in the piston group. Now, if you're at all like me, when I did this analysis, I was pretty surprised. Because it seemed to me that the strut group was just hearing, here's new technology, suck it up. And the piston group was getting some very detailed and explicit instructions about how the technology was supposed to change the way they work. So why is this the case? Well, let's first take a look at this line here, the solid line, and look at the features and try to drill down on that a little bit. If you look at these 12 features along the left side of the screen, these are 12 modules in CrashLab. Each can be used independently of one another. Okay? And you look at the piston group and the strut group, you'll see what I've done here is I've divided things into 2 periods. Week 1 through 13, right around that inflection point, and week 14 and 15. So what happens at week 13? Remember I mentioned before that the groups were on the same track in the vehicle development process, and that's why I picked them? Well, week 13 is a really important stage gate in the vehicle development process. It's called virtual mule vehicle assembly. And at that point, what happens is that the design of the vehicle has to start getting solidified. And so the amount of time that engineers can sort of explore and try out different designs starts to reduce pretty dramatically And they have to get very serious about particular designs and start following those through. So intuitively, it makes some sense that their free time, if you will, right, gets dramatically reduced after week 13. So that breakpoint in the data seemed to be a good way to divide these into two periods, right? So before this VMVA and afterwards. And if you look at the number of features that are being used in these two groups, what you see in the first period is that there's lots of people using lots of features all over the board. But when you get to weeks 14 through 15, again, this is just these numbers represent an average of the ratings taken over that time, you see an interesting pattern. The struct group certainly reduces the number slightly of features that they're using, but they consolidate the features into these first 6. Rarely is anybody using features 7 through 12. In the piston group, right, we see that the numbers pretty much drop off. So there's some divergence in the different features being used from week 1 to 13. And in the strut group only, there's some convergence amongst the different engineers on what features they're using. Okay? So this will be important in just a minute, so we'll get back to it. But if we take a look at that second line, right, which was the number of engineers using the features, and we want to explain, well, why did the number of engineers drop off? Looking at some interactions between members of the piston and the strut groups might help to explain this. So here's an interaction between a manager and an engineer, just around a routine kind of task that was due. And this is roughly around week 20 or so after CrashLab is implemented. And a manager says in the course of conversation to the engineer, you know, we've got to get those results quicker because I have this important meeting on Wednesday afternoon. And the engineer says, okay, I'll see if Rachel, who's another piston group member, can help. The manager says, fine. And are you configuring this analysis in CrashLab? And the engineer says, no, I can't do it if you want it that fast. And the manager says, okay, well, that's too bad, but just get it in. Right? The analysis is more important to me, that you have the results, than that you used CrashLab. So the engineers are evaluating how well CrashLab works against what? What they heard that CrashLab was supposed to do, right? They're being good employees. They said, the managers, the bosses said the technology is supposed to do this, supposed to make your work faster. They do some comparisons. They're finding out CrashLab is not really making their work much faster. And ultimately, because deadlines and pressure start to increase after VMVA, they don't have time to just try out CrashLab for the sake of it. Instead, these reports need to get in quickly, and they're doing them as expeditiously as they possibly can. And for most of them, that means not using CrashLab in order to get these reports done. Now, the strut group has a little bit of a different understanding about CrashLab, right? A much vaguer one. So look at this interaction between engineer 1 and engineer 2. They're talking about an analysis, and engineer 1 says, I ran some of the pulses for this vehicle we're working on with a revised cross-car beam, and they looked good. And engineer 2 says, well, was it good even with the initiator in the rail? And engineer 1 says, yeah, it was fine. We're basically in the range that we need to be in. Engineer 2 says, okay. Engineer 1 says, well, thanks for doing it in CrashLab. It was easier to pull up the nodes. And engineer 2 says, yeah? Okay, good. Do you hear any reference of speed in this at all? No. Engineers in the strut group are not looking at CrashLab as a technology that can help speed up the way they work. Instead, they're charged to figure out what CrashLab is supposed to do to change their work, and they don't really know. And instead, they're experimenting, right, with different ways of using CrashLab. And one of the things that they find is that CrashLab is a very good tool to use if they want to be able to compare results across different engineers. Why? Because it standardizes the inputs and the outputs of the models, which provides for nice comparison. Now, that takes longer to do than just building a model the old-fashioned way, but they find some benefits in the comparison function. So they still have the same deadline pressures that the piston group does, but they're not making a determination about whether CrashLab is useful by comparing it to existing tools. Right? Instead, they're saying, does my use of CrashLab give me an advantage in doing work that I didn't previously have? And their answer is a resounding yes. It allows us to compare our findings, and that is valuable even though it might take a little longer for CrashLab to allow me to do that. We think it's worth the extra effort. Okay, so we see engineers converging, right, on a common deciding to keep using it because they think it's useful in the strut group, right? And they've constructed their own understanding of why it's useful. It allows you to compare. And we've seen them converge on a common set of features that they're going to use as a group, right? And I won't go into it in this presentation about how they converge on it, but you can read a little bit about that in the paper, why they sort of decide on these features collectively. We see in the piston group, they decide CrashLab doesn't speed up the way that I work. Therefore, we're not really going to use it. Their numbers drop off dramatically after week 13, and whoever's left using it is kind of using it willy-nilly, right? They're using feature 1, feature 6, and there's no real sort of concordance in use across the different group members. So, given that we have all of these data, let's remind ourselves about what the managers said. They said, you know, if you're using this tool, right, this is a quote I presented to you before, just an excerpt. If you're using this tool, in consultation will hopefully happen in different areas. I hope the discussion among crash engineers will be in areas related to the analysis of their models. So if we were to think about how are we going to measure change in the organization and the patterns of communication, what we should see is a move from consultations or advice seeking around setting up a model to analysis, to advice seeking around how to doing an analysis, right? How to build a better vehicle. And based on what we've seen, would you expect this to happen in the piston group? Probably not, right? Because they basically stopped using the tool or they reduced it quite dramatically. We might expect to see this happening in the strut group, though. So let's take a look. Based on being with these guys for a long time, doing work before, observations with them before CrashLab was implemented, I determined that there were sort of 3 important advice-seeking practices around model setup and 3 sort of important things that engineers needed to know in order to analyze a good model. And so what I did is I went through all of those observation data, all the observation data I had, and coded from it instances where one engineer asked another engineer these model setup questions or model analysis questions. And what you see if you just run a simple estimation of the difference in the variance across them, if you look at the means for model setup and analysis in the piston group, you'll notice 2 things. First, the means for consultations around model setup in the piston group are much higher than the means in model analysis, right, indicating that the managers had a good estimation that people were talking a lot more about model setup than model analysis. And between period 1 and period 2, there was no change really in the piston group. But if you look at the strut group, you see that these numbers start basically invert, meaning that they decrease the amount of model setup consultations between period 1 and period 2 and increase the number of model analysis consultations. And then the analysis of variance indicates that these differences in means was statistically significant for the strut group, but not for the piston group. Now again, I only had this observational data from after the technology was implemented, because that's when I started observing these 2 particular groups. So we can't really figure out very well from these observational data, did the implementation of the technology enable these changes in any real way. But I have the network survey data, right, which asks these same questions before implementation, roughly at week 12, and then at week 52. And so if you construct these sociograms from about model setup and model analysis consultations for the piston group, what you'll see is roughly similar kinds of results, right? The network is much more dense, right, for model setup across all 3 time periods than it is for model analysis in the piston group. And if we look at the strut group, what we see, visually at least, is that this network in period 2, so this is after VMVA, right? So this is the time when those engineers start to converge on a common use of features of CrashLab. That network starts to become much sparser and denser down here for analysis consultations, suggesting that implementation of the technology and just use of it didn't seem to shift the way that the strut group was interacting with one another. It was not until they started converging on a common set of features that everyone was using the same features of the technology that their work shifted in similar ways, right? So their work unilaterally started to move away from model building and allowed them to do more model analysis. And then because all their work had shifted in a similar way, they could start talking to one another about analysis-related things. So the convergent use of features, this is what I think is going on in the data, right? Shift what they're working on, which then shifts what they talk about. And that's why we see this change happen only between period 1 and period 2, and not between the time when the technology, before and after the technology is implemented. Right, so it takes something additional to just the technology implementation to bring these kinds of cascading changes. And I won't go through this all the way, but as I said, these kinds of these sociograms, I think, visually tell the story pretty nicely. But if you take a look at a difference in a density analysis right across the networks and the structure of the network with a quadratic assignment procedure, basically what you see is that for the density, the density is different, right? So the density analysis is measuring the difference in density of the networks between period 2 and period 1 and period 2 and before implementation. There's a significant difference for the setup and analysis networks in the struct group, but not for the piston group. And if you look at the structure of the networks in terms of the clap, what you see is that the networks are between period 1 and implementation are very similar. So implementing the technology really didn't change the structure of those networks. But after convergent use, then you don't see a significant correlation anymore, which suggests that the structure changed after they began converging on a set of practices. One final step. There's change in one group, there's not change in another. And what do these folks have to say about it? What do these engineers say? Do they realize this change is happening? To what do they attribute it? Well, engineers in the piston group were pretty clear. I keep hearing CrashLab's supposed to make setting up models faster. I think that's bullshit. I mean, I don't think it can do it any faster than I can using the methods I use now. I even did a side-by-side comparison. I did all this kind of stuff, right? And CrashLab was still slower. So that's why there's been no changes here. Right? No changes because CrashLab was not a very good tool. We don't hear the same story from the struct group. Well, I'd say CrashLab, you know, pretty profound. It is what it is. It's like a quasi-preprocessor that sets up your models for you. I think what's been really good is that most of the people do a bit more in terms of, you know, thinking about changes in design and whatnot. But that's the natural outgrowth of using it, I think. I mean, that was basically what made it happen. So, in the end, who's giving a real specific discourse? The struct group. They're saying CrashLab was supposed to change our organization in this way, that we were supposed to use it to be able to compare across our different kinds of analyses, such that we could then talk about analysis with one another. Why does this happen? Why is it that the struct group comes to believe this, and consequently management says, oh yeah, you know, struct group, they had it right all along, the technology did what it was supposed to do, and the reason it didn't work with the piston group is because they screwed up somehow. Right? It was operator error, which is exactly what they say. Okay, so what have we learned, and how might this help to explain what's going on in this story? First, we have engineers in two almost identical groups are exposed to different framing tactics. When the time pressure is low, they're appropriating those features of that technology in all kinds of different ways, what I call an exploratory pattern of appropriation. And when the time pressure is high, the engineers are drawing on the frames that they hear, right, to then more strategically use CrashLab because they don't have the leisure or the luxury of experimenting with them lots of ways. So we have a sufficient number of engineers, right, some critical mass at the level of feature use, right, are appropriating these features in convergent ways, which ultimately leads to a change in their work. So engineers in the struct group then viewed the resultant changes as the only possible outcome when reflecting on the frame of reference set by the discourse. Okay, so what kind of implications might this have for some theory? Well, first, managers and implementers really can create, either strategically or inadvertently, right, a discourse with which users evaluate the functionality of the technology. And that this process of implementation seems to be very important, helping to explain stasis or change in communication networks over time. And that these effects don't emerge from work culture alone, but it really has to do with how they use the technology to change their work in substantive ways. That the technology, and I think this is a real important point, must be appropriated in convergent ways to become a structural property of organizing. That is, people can use the technology as the piston group was doing without bringing any change in their work. And indeed, the piston group used the struct group used the technology for almost 3.5 months without any change happening in the way they communicated. And it wasn't until they converged on a common set of features that then it was used as a resource to change the way they structured their communication practices. So we need to pay attention not only to if the technology is used, but how it's used. Is there critical mass at the feature level? And that technology could become a resource for structuring in this way. And finally, the alignment between frames and work practices may help to explain how technology is used. And here's, I think, what one of the most interesting findings from the study for me is, and that is that a plastic discourse, one that's broad and generic, allows people to see what kind of changes naturally emerge from their work and then reflect on that discourse and say, were these the kind of changes that were supposed to happen? Well, they said we were going to change in some way, and we got these changes, so this must have been the way we were supposed to change. But a very specific, ill-informed discourse leads people to then reflect and say, did we change in exactly the way they told us to? No. Therefore, we should reject the technology, and we won't get any of the kinds of advantages from it that we might have. So I think this is a bit counterintuitive, right? That you might want a more generic kind of plastic definition, right? And this is the, if you're familiar with the literature on boundary objects, they make roughly the same kind of claim, right? That a good object that helps groups coordinate expertise across boundaries is one that can be interpreted in lots of different ways at the same time. Similarly, discourse around technology might be most effective if it's plastic, allowing people to then say, this is what I'm supposed to do because the discourse allows me to. If managers, and this is usually the case, aren't ever exactly sure how people in their organizations work. So I'll leave it there, and hopefully you have some great questions and insights for me. Thanks. Andrew.
So I have a comment first, and then I have questions about your presentation. So first of all, with regard to comment, one of the things that I thought you did really nicely, and this is a comment directed also towards all the graduate students in the room. You set up your problem and you situated your work very nicely at the very beginning of your talk. And for graduate students, I think in the job talk, that's definitely something you want to do. You talked about the large research questions that guide your work, and then you had very nice 2x2 that situated all of your papers within a framework, and then you talked specifically about what you were going to talk about in the study. So that was very nice.
Good. I'm glad that was
so
useful.
I just wanted the graduate students to see and think about that for their own strategy in the future. Okay. So here, all right, so now I'll move to my question about the work.
Now I load the animal.
Yes, now. So one of the things I thought was interesting is your discussion at the end about the plastic discourse.
Mm-hmm.
Now, obviously, the question is, perhaps the organization wants to have other groups use CrashLab.
Right.
So the question is, how does the organization do that? Because there has been some learning, right?
Mm-hmm.
That they've learned that the group that emphasized the benefit of standardizing comparisons used the technology more efficiently.
Yes.
So what recommendation might you give based on the findings in terms of next steps?
Mm-hmm.
So, here you suggested that, well, maybe a plastic discourse is good, but then you see that this one group implemented it more effectively by emphasizing the standards part. So
right.
That was one part. And then also I wondered in terms of performance,
Mm-hmm.
if there were any differences in the performance between the two groups.
Yeah, that's a great question. Let me answer the performance one first.
Okay.
And that is, this is something that, as you might imagine, a company like Autoworks struggles with a lot. And it might not be surprising that they don't have very good metrics for performance at all for engineering work. Now, they do have excellent metrics for manufacturing, right? And we can speak to some of this. But for the engineering aspect of it, they don't have very good metrics at all. And so they really struggle to know how are engineers being effective or not. And so this was part of my dissertation work. And I tried to work with them quite a bit to say, well, I'd like to get some performance, right, and be able to correlate this with some increases in performance. And it was just so painful to try to figure out what we could do to use as performance metrics that eventually I just had to give it up. And I think that that's a major problem. Could be a problem with the study because it would be nice to show those performance increases, but it's also a major problem with Autoworks, right, that they don't have very good performance metrics. So the first part, what sort of the continuing story with this is that management, of course, had no clue what had happened. they didn't know that one group rejected it and the other group was using it, right? And they really had no idea. And so they convened this big meeting because, you know, it was part of my responsibility as a field researcher, my contract with them, to go back and present some of the findings. And so I sort of explained, well, this is what's going on here. And they said, oh, great. So now we're going to tell everybody that it should standardize the way that you work. Right? And so they went around to the different crash groups and, you know, to the fork group and the, you know, the spring group and the shock group and all these different groups. And they said, it's going to standardize your output. And in this case, that was very well received, because most of the engineers across the organization wanted to be able to compare their results and felt very frustrated that Peter and I are doing very similar kinds of tasks, and there's all this knowledge that's being created, but nobody can exploit that knowledge, right? It's sitting basically in these models and in the charts that we produce from them. So they were really interested in doing that. So in terms of, well, what do you do, right, sort of more from a theoretical standpoint, right? Well, what do you do with this kind of thing? I think that one of the lessons that we might learn is that for an initial implementation, the model that I've sort of demonstrated here might be a good strategy. And that is that you allow, at least maybe with a beta group, right, you allow for this more plastic kind of discourse. Let the people who really understand the intricacies of their work and how they would use the technology come up with some recommendations for how it changed the way they work in important ways. And then you can use that as specific discourse that's well aligned now when you talk to future groups. Because the major problem here was that management didn't know how the people worked, and they picked a specific kind of frame of reference that was wrong.
Yeah, but then,
and that's very common, right? So I think to overcome that gap between management's knowledge of the work and workers' experience of the work, having that plastic discourse at the outset might be important. And then you can shift to more specific, well-aligned discourse over time.
Wally?
Just to follow that up, do you have any observations or hypotheses on why the piston group initially focused on the narrow discourse and the strut group focused on the broad discourse? Was it management that basically focused them in that way, or are there some other things going on?
Well, in terms of, you know, being a part of hearing those different frames, like I said, the managers who were in the piston group had more ties with the R&D folks. And so R&D specifically developed this with the idea that it would speed up some of their processes. Now, of course, R&D doesn't know what any of the engineers do either, right? But that was their idea, and they were able to communicate that to managers who then communicated that to the piston group. The strut group's management didn't have those kinds of ties. And it also turned out that the way that the training unfolded was that Autoworks has its own institutional training center with trainers, and then they also bring in vendors to do training. Now, although CrashLab was created in R&D, it was actually coded at a vendor firm. So what you get is the vendor firm is very involved with the development group and also knows that it's going to speed up the way that they work, right? And so it's the piston group that gets the training from the vendor. And it's the strut group that gets training from Autoworks Institutional Training Center. And they're training people on tools all the time. I mean, so, you know, they get a tool, they take 3 weeks to learn how to use it, they talk with a few developers, and then they teach people, here's the functionality of it. And so they get confronted with these sorts of questions. Well, why do I have to do it in this order? I don't like it. And this is largely a defensive tactic on their part, which is, whoa, don't blame me. I'm not the one trying to change the way you work. It's the technology that's making you do this. So they're propagating this kind of broad discourse because they don't have any of the specifics about how the technology is supposed to be used. So I think initially that's why they get these very different frames of reference. And then because they're engineers in their routine work, having to learn a new technology, they say, you tell me what this is supposed to do, that's what I expect it to do. And that's why they're doing some evaluation.
Matt?
So following up a little bit on what Wally was asking, were you able to look at differences between the structures within each group? So for example, in the piston group, did the managers within that group who are overseeing the engineers have a different orientation towards speed? We talked a little bit about speed from the R&D group, but speed within their group, did they have a different emphasis on speed? And they had issues with that in the past. And secondly, with regards to your table that showed the features that were used, were there differences in the tasks that each group was focused on? You know, for example, if it was Honda Accord versus Honda Civic, were there different design features that led two different tools within CrashLab being used?
Yeah, both great questions. The first is that both of the managers in both groups would be ecstatic for a tool that would speed up the way that people worked. Both really want that. Because if they speed up the way that they build models in particular, they can do more iterations, which means that instead of just sort of this iteration seems to be best, the goal is that we could move towards optimizing our design, right, rather than just kind of troubleshooting designs. So they both want things to be sped up. But the managers have differential access to these developers as well, and differential understandings of what CrashLab is supposed to do. And so managers in the piston group have an idea it's supposed to speed up, Struct group doesn't. In terms of your second question, there were no, you do crashworthiness work, the only differences are between subspecialties within the crash discipline. And on a vehicle program, each of the teams is organized to include members from each subspecialty. So you have someone who does frontal impact analysis, occupant analysis, rear analysis, someone who does pedestrian protection. They're all in the same group. So within those specialties, you would expect different features to be used. My hope was that because I looked at the entire group, that those differences would wash out as you aggregated across the entire group. But between groups, there's no difference really in the kind of analysis they're doing. There's the federal motor vehicle regulations specify if you're doing a 216 frontal impact analysis, you have to set the formable barrier at 64 degrees to the vehicle and all this sort of thing. So they have to follow those in similar ways. Now, there might be some slight variations in design on the analysis end, right, in terms of the front rails of a Accord are much longer than a Civic, so there's more crush space. So there'd be differences in design solutions, but I was only looking at not the content of their consultations, but what they were, basically what they're talking about. Right?
The gentleman in the back and then Cindy.
Just the quick corollary, you have described differences in management. Is there any differences in the engineers? Or one group younger or more open, one group older, less open, or whatever?
Very good question. I looked for some demographic differences between them. There's nothing in terms of education. Almost all these crash engineers either have a master's or PhD in structural engineering or thermodynamics or something like that. Just by chance, I think that the Struct group was slightly older, but not by anything noticeable. And I couldn't find any other sort of demographic differences that would have accounted. They sat in the same building, but on different floors, right? So they didn't interact with one another directly. They did interact with some of the same design engineers occasionally, but
basically you said the engineering groups had a similar deal.
I think that they're relatively similar. And that was part of the reason why I picked these two groups, and most of the crash groups are similar. Now, if I was going to move into a different category of vehicle altogether, so Autoworks does some tractor kind of design for large tractor trailers, right? And they'll do some safety analysis on those. And the profile of the engineers tends to be different in those groups. So I tried to stick with groups that were similar in demographic content profile.
Okay, I think our last question will be with Cindy.
Did you observe any difference in terms of the engineer's sentiment toward the technology, in terms of their acceptance or resistance? Because I would imagine that for the group adopting the narrow frame, because they receive very specific expectations of what technology would do, they will feel, more acceptive compared to those who receive a very broad and ambiguous frame of technology. Is there such a difference?
Wait, accepting is what?
Like they would like to use the technology, and versus they have a resistance towards using that technology or exploring its features.
Yeah, that's a good question. I didn't, did I? No, I don't think I did. I looked sort of just broadly in the data, right? I didn't quantify the differences, but to see in that first period of time, is there more indication that engineers in the Struct group are trying it faster, right? I mean, so they've gets implemented and like the first day they try it rather than they wait a week or two. I think that there is a slight difference there, right? Again, I haven't quantified it, but I think that there is a slight difference there. That the Struct group was more excited about using it than the piston group was, because they want to speed up this aspect of their work. They think of it as the scut work. And at a strategic level, Autoworks is trying 2 different avenues to reduce this work. One is to automate it so that the computer does it and engineers can focus on analysis. And the other is offshore to India, right? So that the Indian engineers are doing that work and all of our best talent in Detroit is doing analysis related work. So across the board, there isn't a de-skilling phenomenon or a de-skilling fear going on here where they're thinking, oh, my job's going to be replaced by the computer. Instead, they're really excited about not having to do routine model setup because it's just a matter of like going to the regulations and setting up the models accordingly, and instead focus on the analysis. So I think that the Struck group was more excited initially because they'll speed up the way we work, fantastic. We really want it to do that. And then the piston group, of course, was, well, all right, we'll try it out, but we're not sure exactly what it's going to do.
Okay, I'm sorry, all right, I'll give you, again, a first-year doctoral student is asking to talk, so we'll definitely give you the opportunity.
We should definitely let her.
Thank you. I was just curious, just kind of your last question, if any of the discourses of this creativity, talent analysis were stronger or weaker in either group, and if you found that to be influential.
What do you mean?
Sort of the, you looked at specifically at the discourse of technological determinism, and I was wondering if there was also present sort of the clear discourse of accepting this idea of analysis and creativity and sort of talent as.
Oh, I see. Yeah.
And I was wondering if that was present at all.
Yeah, it was not present. And the only reason it wasn't, I think, is because it was already so institutionalized as, well, of course, right, you guys are really smart, and of course you want to get rid of this kind of work, that it wasn't actively talked about by anybody. And the first time I went to Autoworks, and I spent about a month and a half there doing observations across different divisions, and that was very clear. I mean, it didn't come through in sort of active pitches by any management, but it was very clear that we think you need to be doing the high quality work, and that this lower kind of quality scut work should be sent elsewhere. Now, we have a couple of papers that talk about how important this model setup stuff actually is, and the real disadvantages of the organization thinking that it's not important, and especially the outsourcing to India part, where they try to outsource it because they think it's not important, and then they find out very quickly that it's some of the most important things that they actually do. That's a different story altogether. But I think that stuff was more subtext at that point when I got there.
One thing that might be interesting to explore with this plastic interpretive context that you talked about is the work of Eric Eisenberg on strategic ambiguity. This just sounds to me like very much of that kind of a context in which he's working. If I can think of that. Our speaker next week is Ramesh Srivinavan. Is that correct? Yeah. Okay. Did I say that right? Okay. He's from UCLA. And this is going to be an ARNIC-sponsored speaker next week. And the title of his talk, fitting followingly and appropriately on today's, is Exploring How Cultures and New Technologies Shape One Another. So I hope you'll all be able to come back and join us for next week. Would you join me in thanking Paul for a really important